Assalamu alaikum. Dear students, we are going to discuss about Pearson Edexcel GCSE 9-1 linear paper. It's basically June 23 paper 1. Okay, so here we go. I'm Ayaz Ahmed and discussing physics problems with you. Hopefully, there would be some issues which would be critical for the students here. I'm trying my best to manage all those at as easiest level as possible. So here we go. This is the formula sheet given to you. Let me give you some short introduction about the paper. Basically, this is your paper 1, and in this paper 1, what we have to do, we have to attempt all these questions. It is of 110 marks, and that is of 2 hours paper. Okay, so definitely once we are going to have this all discussion, uh, this is very important to know that how to get the grades and how to improve this, how to improve the grade strategy. So the formulas are given to you. The first of all, what I emphasize when I teach, that is the things which are given to you, you have to be, they are basically your legal you know equipments, and you are equipped with these all tools, so you have to take care of them and you have to know how to use it. So first of all, you have been given with this the formula of the energy in terms of EMF, yeah, voltages, current and time, and then you are given with the formula of frequency and time period, then the power burden per unit charge, unit time, and again powers, another formula burden per unit time, and then the orbital speed of the stars moving in the orbits or planets moving around the stars, that is 2 pi r divided by t. And then this is the equations of motion, and this equation is given to you: v square is equals to u square plus 2as. That equation deals with the equations of motion, kinematics topics. And then we have the equation of transformers, that is P1 V1 equals to P2 V2. Sorry, equation of pressure. Sorry, unfortunately, I was thinking that it is the equation of power. No, it is the pressure equation. P1 V1 is equals to P2 V2. And then this is again the pressure equation. P1 divided by T1 is equals to P2 divided by T2. So once we are familiar with this all, we will be able to manage this. And the value of G, you have to take 10 meter per second square. So here we go. Let's talk about question number 1. There's a mixed flavor questions. Sometimes we have MCQs. Most of the time the questions are blend together. So here, this some questions must be unanswered with the class, right? They must be having a MCQ selection. For example, this is question number 1. This question is about the electromagnetic spectrum. Okay, and in electromagnetic spectrum, we have to talk about that. We have to take care of all the knowledge or information we had in our previous level for electromagnetic spectrum. Yes, all electromagnetic rays. Sorry, the question is place 3 ticks in the table, 3 ticks in the table shown in which the statements are correct. So each statement has 1 mark. So once we are going to place 3 ticks, so here we go. All electromagnetic waves are longitudinal. No, it is not possible. Rather, none is longitudinal. All electromagnetic waves travels in the same speed in free space. Yes, this is the correct value, correct statement. Radio waves have the longer wave. That is, yes, the radio wave have the longest wavelength in the electromagnetic spectrum. So for this purpose, I told you GXULIMR. So gamma has the shortest wavelength, whereas the radio have the longest wavelength or largest wavelength. So that is why this is the true statement. X-rays has the highest frequency of the electromagnetic spectrum. No, gamma rays have it. Then electromagnetic waves transfers energy. Definitely they have. They all transfer energy. All electromagnetic waves can cause cancer. No, not all. Only gamma rays and X-rays. So this is a technique how to attempt these questions at a shorter distance. Then electromagnetic waves can be useful but they can also be harmful. Give one use and one harmful effect of the microwaves. Microwaves. So we have to figure out that which wave we are dealing with, and now we are going to have its useful. I mean, you can simply say it is advantage and disadvantage. Okay. So once we are talking about the advantage and disadvantage, it means that microwaves are used for communication, right? One of the positive use of the microwave is communication, cooking, right? Radar communication, and so on. So you are familiar with all these. Radar or satellite communication, right? So basically, as generally I told you that they are useful in communication. And what are the harmful effects of that? The harmful effects of the electromagnetic radiations are again very simple, and they are, once you are dealing with the harmful effects of the electromagnetic, gamma rays causes cancer. That was the only wave which is used as the cure of cancer, as well as they cause cancer. So sorry, I have to talk about the harmful effects of the microwave. Harmful effects of the microwaves are not that much, but that can cause burning if you are using in cooking. Then its intense use can cause some damages to our listening, or in our listening effects. Okay. Intense use can cause damage in the hearing system. Although their frequency is not that much that we can hear it, but unintentionally it damages our hearing system. You can give a useful use and one harmful effect of the gamma rays. So as I told you that this is the only ray which is used to treat the cancer, that is used to trace the cancer, or it causes the cancer. So it is used as a tracer of tumor, or you can say that that is used to cure the cancer. Okay. And what is the harmful effect of that? The harmful effect of the gamma rays is actually your it causes the cancer. Okay. What does it do? It actually causes cancer. So I can say it causes tumor or cancer. Okay. The next question is question number 2. So for at the end of every question, you have this information that how many total marks do we have, and yes, from this it is very clear that yes, we can score this much marks. Then in question number 2, that is the photograph shows the International Space Station ISS in the orbit around the Earth. The ISS orbits the Earth in a circular orbit. Which of these also orbits the Earth? A comet, Mars, moon, sun. So definitely the moon. Okay, the moon orbits the Earth. Then which of these forces causes the ISS to orbit the Earth? So which force is basically used to move the bodies or to orbit the bodies in the circular path? They are your gravitational forces. So here we go. That is the gravitational force. Then now it is the question related to the structure. The ISS completes one orbit around the Earth in the time period of 93 minutes. It is basically its orbital time period. The orbital radius of the ISS is 6.8 into 10 to the power 3 kilometers. Calculate the speed in kilometers per second. Okay, so here we go. As I told you that this is the orbital time period. This is basically orbital radius. So the formula I told you in the marking scheme, sorry, in that formula sheet, that was orbital speed is equals to 2 pi r upon t. So 2 pi r upon t means 2 pi, and r is 6.8 exponent 3, because I have to write the answer in kilometers, so no need of conversion of this from kilometer to meter. But the thing I have to do, that is I have to change the time to seconds. So there are 93 minutes, and I'm going to convert them into seconds, multiplying it by 60. So let me calculate that from my calculator. Okay, 2 times pi times 6.8 exponent 3, and it is divided by 93 times 93 times 60, sorry for delay. So that its orbital speed is 7.66 kilometers per second. So I have to round it to two significant figures, so that is 7.7 kilometers per second. Is this clear to all? I hope that it would be very easy question. Then show that the ISS completes approximately 15 orbits around the Earth in each day. So its orbital time period is given to you. The time period is 93 minutes. Okay, this is the orbital time period. And what is the time in 1 day? That is 24 hours. Okay, so I have to complete the number of turns, yani the time taken, total time, okay, sorry. Basically, there was I forgot to connect charger with my laptop. That's why there was a disconnection. Okay, so I was talking about that this is the total time. Okay, so total time is equals to number of orbits into time of one orbit. So that is 24 hours into 60 minutes. I will convert that into minutes, and that is equals to number of turns, and then 93. So here we go. Once you are going to divide the number, it will be 24 times 60 divided by 93. So you got 15.4. Okay, so the answer is 15.4, which is approximately 15 orbits. So I hope that this would be clear to you. It was a kind of easy question. Then moving to the next part of the question, blank page. And now here we go. This question is related to your you know, stress and strain and deformation, basically. The model electric motor is used to lift a load through a vertical height. The power supply is given joule meter, which measures the energy. Okay, then load is there, then electric motor is there. This all setup is available. And once you are going to, yes, once you are going to use this, a load has a 15 sorry, a load has a mass of 400 grams. This is the information. Gains 3.2 joules of the energy, um, as in its gravitational store when it is lifted. Okay, so once it is lifted, it means it gains the energy of this 3.2 joules. That is the gravitational potential energy. State the formula that links the gravitational potential energy, mass, and this. So I prefer to write a word equation. That word equation means gravitational potential energy is equals to mass times gravitational field strength, gravitational field strength times the height traveled. Okay, then calculate the height lifted by the load. That is, I will use that GPE again equals mgh. This is just to rearrange that all, not a big issue. So once I'm going to rearrange this all, that will give me a formula. For example, now height is equals to gravitational potential energy divided by mass times value of g. So you have, for 3 marks you have to use all that pattern what I have solved for you. So height is equals to, what is the gravitational potential energy? The gravitational potential energy is basically 3.2 joules. Okay, 3.2 joules, and mass of that load, that is 400 grams. So I will use it into kg. So 0.4 grams, 0.4 kg into 10. So as you were instructed to use as 10, so it is, I'm gonna solve it. For the calculator, I will recommend that you will use 3.2 divided by zero point 0.4 into 10. Zero point 0.4 times 10. So it is 0.8 meter. Okay. So that is 0.8 meter. Next, the load is lifted at a constant speed. This is very important information, that the load is lifted at a constant speed. The diagram 1 shows lifting force acting in the upward in the load. Draw the labeled arrow diagram, labeled arrows on the diagram 1 to show another force that is acting on the load. Ignore the effect of the air resistance. So it's obvious that there will be a load acting on this object which is in the downward direction. So if it is acting in the at a constant speed, so your weight will be equal to load. So these two arrows should be equal in length. A joule meter measures the amount of the energy transferred electrically to the motor. As the motor lifts up the load, the joule meter displays that 11.0 joules when the load has gained 3.2 joules of the energy and in its gravitational store. Calculate the efficiency of the motor. So now it's really simple. That what is efficiency? That efficiency is output energy, or you can say useful output energy, or useful output work done. There are so many games. Useful output energy divided by total input energy, total input energy, right? And if I want percentage efficiency, I will multiply it by 100. Okay, I will multiply that at the end. So what is the useful? Actually, motor is lifting the load, so I can say that is mgh divided by, what is the input? Input is in the form of electrical energy, and that is basically given to you and it is okay, I can say electrical energy just for your convenience, not a big deal. I could put the values. So the input energy is this one. This is the electrical energy which is fed to the motor, and this is the output energy which is in the form of the load lifting. So it is 3.2 divided by 11, 11.0 rather, and this is equals to 3.2 divided by 11.0. It is basically 0.29. So because it is 0.29 r, if you want to write your answer in percentage, your answer will also be considered as correct as if you write 29%. Okay, I hope that it would be very clear to you. Now justify why 7.8 joules of the energy must be dissipated into the thermal store of the surrounding as the load is lifted. Oh, very good. When the motor is lifting it up, the motor is providing it the thermal energy, sorry, gravitational potential energy as well as the kinetic energy. So you can say that the total energy is in the form of potential energy or gravitational potential energy, kinetic energy, and thermal energy. This is an additional information, as well as elastic potential energy. I will mention why I have written that. Elastic potential energy is zero as wire is not extended, as wire is inextensible. Ke is zero, sorry, chain in Ke is zero and chain in EP is zero. You can say chain in EP is K is zero because object moves with, or load is lifted at constant speed. Load is lifted at constant speed. That is why there is no change in kinetic energy, and the Gp is lost. Gp is lost. So when an object is moving in the upward direction, actually you can say, oh, sorry, Gpe of the load is gain. So Gp is the energy which is gain over there, the only energy which is in the form of energy gain, that is 3.2 joules. So what is the input? So input is basically that is 11 joules. So I am just giving you a answer which you have to write in your exam, that is that out of 11 joules only 3.2 joules is used as GPE. Rest is in the form of heat energy, you can say. Okay, is it clear to everyone? Yeah, good. Okay, the next is the diagram 2 is an incomplete snaky diagram. Complete the snaky diagram to show the energy transfer by the motor. To show the energy transfer by the motor. So input energy, output energy, and then I can say that there is a waste of energy, or there is basically a loss of energy, dissipated energy as well. Okay, so if I say that the dissipated energy is more, so I can just make this much arrow for that one. Sorry. Okay, this is the arrow, this one. The reason behind that is that this is the waste output. Oh, okay. The waste output is anywhere here. This is not the waste output. Sorry, I have to rearrange that. This is the waste output, so that has the larger energy, or it should be the greater one, and the amount of useful output is small. So I can simply say that this is the useful output. So once it is the useful output, we have to make a shorter diagram here. Actually, what is the game of snaky diagram? Mostly we check the average rate. For example, this is a grid. So in the grid, if you think that this is the 11 joules energy, then this is your this is your 3.2 joules energy, and this all must be then 7.8. Okay, this all must be then how much? 7.8 joules. So this is basically the situation of the snaky diagram. So for the snaky diagram, if you think that the plot shows you that is an approximate value, that almost this entire arrow or the area under this shows 7.8 joules, then this shows 3.2 joules, and this 0.11. So this is basically the input energy and so on. And here we go. This is the next question. Question number 4. In this question, we are basically at the point. This question is about the magnet. So which of these substances is not attracted to a bar magnet? So definitely nickel, cobalt, iron, they can be magnetized, but copper cannot be magnetized. So this would be not attracted. The diagram shows a bar magnet. This is a bar magnet. So what we have to do? Draw magnetic field lines on the diagram. One, show the shapes and direction of the magnetic field lines around the bar magnet. Shape and direction. So as I told you, that for this purpose, what you have to do, you have to draw at least 3 lines. You can draw 5. 3, 5, 7 is suitable. So if you are going to draw 3, 1, just plot 3 dots here. 1, 2, 3 dots here. 1, 2, and 3 dots here. Just draw. Just try to draw as a diagram as effective as possible, because you are drawing at the paper. So I hope that it would be helpful for you to draw on the paper. Right, these are the 2 magnetic field lines. This is the magnetic field lines. This is the magnetic field line pattern for 2. So magnetic field lines are basically they have the direction from north to south. Either you can draw this one, or you can have another field around this. This will also show the strength of the magnetic field line varies in this way. This is good that you draw 5 field lines. Sorry, if you draw 5 field lines, and if these field lines are here, yeah, these are from north to south. So this is basically the pattern of magnetic field line. So the important thing what I wanted to mention in this all, that here around this is the portion of the weak field, right? So you have to mention, no need to mention because it would be asked, but the field line should get apart from here, weak area. So apart lines, this is basically because I'm explaining you the paper, that is why I have to mention here. The same goes here. This area is the strongest, that is why this is the strongest area. That is why what you have to do, or what you have to manage, that the field lines are very closer to each other. The closest lines are strongest field. Now moving onward, some bar magnets are made for steel. Explain why steel is good material for making the permanent magnet, because steel has a property, or steel has a tendency to keep the magnetic field, or to keep the magnetic properties for a long time. So you can simply say that the steel holds the magnetic field or magnetic properties. Steel holds the magnetic properties for long time. Okay. Or you can simply say that it is easy to demagnetize the steel. Sorry, it is hard to magnetize and then demagnetize the steel. Magnetize and then demagnetize the steel. Okay, moving onward. This is a question related to the magnetic field lines in a in such a way that we have a current carrying wire, and that current carrying wire is basically placed in between two magnetic field lines, or two magnetic poles. And that is why, what do? We have to draw basically, the wire will experience a force, and when the wire will experience what the diagram shows cross section through the wire placed in between the two magnetic poles. The direction of the current in the wire is out of the page, yani it is out of the page towards you. So you know, draw an arrow in the diagram to show the direction of force acting on the wire due to this magnetic field. For this purpose, you have to apply Fleming's left hand rule, and that rule means you have to point your hand in the direction of south. Yeah, in the direction of south, because magnetic field is in the upward direction, right? Point your hand in the upward direction, yeah, to the top of the page, then split your fingers, and after splitting the finger, rotate your full arm in such a way that the magnet current is pointing towards you. So your middle finger should be pointing towards you, then your thumb is pointing left. That means that you have to show your thumb in the you have to show that the direction of the arrow is towards left. This is the direction of the force basically, which is acting, which is produced by the magnet, right, due to two magnetic field lines, right? So that is only one. Assume that the magnetic field is uniform. Yeah. State the change that would decrease the magnetic field lines, magnetic field and the force on the wire in diagram 2, right? So what are the two changes due to which the magnetic force can be decreased, right? Decreases the magnitude of the force. So as I told you, that this force is directly proportional to current in the wire. That force is directly proportional to the strength of the magnetic field line. So if you reduce both of them, reduce the current. This is the simple logic. And secondly, reduce the current in the wire and reduce the magnetic field strength. Yes. Okay. So these are the four questions. The fifth question is related to your kinematics and dynamics. I will discuss that question in the next episode, inshallah, because your video is extended more. So I will solve all these questions bit by bit. So first four questions is there. In case of any confusion or in case of any problem you want to discuss, you can contact me at 0346 3011502. It's a WhatsApp number, as well as you people can basically contact me through comments, etc., etc. Okay, see you then, inshallah, in my next video, the next part of this question paper.